So, first of all, thank you very much to having the chance to present our solutions there. And I will give you a rough overview about our technical solutions about a large-scale 3D printing. And afterwards, I will give you a small site in two of our projects. So, yeah, and maybe if there is an interest, you can visit us on the booth C29 or D31. Yeah, first of all, is the question, what is what we do? So we are experts in, let's say, substitution. The core business is to substitute conventional processes and materials with our innovative processes and materials. And we are in the branches caravanning, e-mobility, transport, wind energy, and micromobility. So what you can see there is are some examples for some substitutions. For example, on the upper side there is a laminating jig. It's almost a big advantage in prototyping, because when you laminate only, let's say, 10 pieces or 20 pieces, it's an advantage to have the chance to recycle the jig after the using, because the lifetime is very short, and you have only also the chance to reduce your stocking time and save costs because of that. Another advantage is to build milling jigs, as you can see on the upper left side. Therefore, we can integrate vacuum channels or other big structures or cavities, let's say, to reduce the material usage. And yeah, what is another big advantage is the usage of different innovative materials. As you can see on the picture, it's light brown. That is a material which is 50% from wood and 50% from PP. And it's the approach to reduce the oil-based plastics in the 3D printed parts. So after we know what we do is the question, how do we that? So we have different engines in our research department. So we apply our seam extrusion head with different linear kinematics and also with robot arms. So it's possible to have very big velocities for printing, and you have the advantage to get very different geometries like organic or bionic geometries, or to have lightweight structures and so on. And yes, fifth one is in process at the moment. It will be a big 3-axis engine with a building room of 2 meters per 1.5 meter per 0.7 meters high, to get really big structures. So what is an example of our printing? So on the upper side, you can see that is the movement from our seam hex 1. This was on the Formnext on the last year to see, and there you can see the guiding of the nozzle 90 degree on the surface of the part. It's to having the optimized thickness of the printed line, also on that banded surface. And yeah, on the upper left side, you can see the seam head on a robot arm. So what is special on that? Special is on that is that you can see the different velocities, also the stopping in between, and you also have all the time the same mass flow. So that's a special patent of our department, to have all the time the same line width while printing. Yes. What we also had is another approach for printing. It's a kind of rotational printing. So on the left-hand side, you can see it's a part which is made for standing against high pressure. In this case, it was 10 bar. And there was no fail in 5,000 rhythms. And we can apply there special plybook, for example. So you have different shells with different line orientations, and yeah, in the end, the result is a really strong part. So on the right-hand side, you can see it's the inner core of a hydrogen tank. It's a liner part which is winded with. Afterwards, there is a winding process, and then you have a CFRP hydrogen tank. And yeah, it's also the nozzle is also guided 90 degrees to the surface to having a leak-proof body in the end. It's the body in the end is apart from 5 parts which are assembled together. Yeah. What you can see there is also the patent from the Fraunhofer IWU. There you can see that we also have a jump between different geometries. So the nozzle closes up in between, and the mass flow is all the time the same in the whole part layer, independent from the position and velocity. Also on the left-hand side, you can see the stub in the angle and so. And yeah, that's, let's say, our process core field. Yeah. What we have as advantage is based on that technology, we are able to print in different angles, not only in 90 degree, also in 45 degree. So in this case, it's possible to print closed bodies, not only open bodies. So we can then print closed bodies without any support structure. So that's very important for us, because we all the time we want to have the most efficient material usage. Another advantage is, as I mentioned before, the, let's say, degree of design, the degree of freedom from design. So you can print different organic structure and lightweight structures. On the right-hand side, it's a machining table. And on the left-hand side, it's the core element of a caravanning seat. So there was the approach to have a lightweight and ecological core in that seat development. Yes, that's also the material which has 50% wood and 50% PP. And another material which we used in a foreign project is the material which is based on grass. It's a kind of cellulose fiber, and it's mixed with 40% fibers and 60% PP. And it's also with the same approach to reduce the oil-based plastics, also in this project. Yes, what you can see on our booth on D31 is our recycling cycle. As the special point on that is that we use, let's say, the typical granulate like injection molding. So I think that's the very normal. And afterwards, as I mentioned before, prototyping jigs like laminating jigs could be shredded afterwards, and then you have a kind of flakes. And the way is to use not only the original granulate, but also the flakes from the shredding itself. So we have a very small cycle then. Yeah. Yeah, that's another material example. There you can see that the CO2 equivalent of PA11 is based on the mass 8.4 fewer than an aluminium alloy. So you can see then that when you print with this material, for example, then you have an, let's say, green part. Oh. Yes. What is our way forward? That's what I mentioned before, the 5-part hydrogen tank. And let's say we want to integrate more and more automatic quality tools. So it's really important for us that we have that we fulfill different quality requirements from our customer, such as leak proofness or surface quality and so on. It depends on how is the printing quality and how good are the parameters steered in before the print starts. So you can see then on the upper side that is a laser scan, and we also work with a thermographic scan to analyze the hotspots, or in the laser scan case to analyze the line height and width. What we also do is a topic to get the printing process in the industry. So as you maybe know, the large-scale 3D printing process could be really, let's say, complex, and it's very important to have the chance to reduce the expert level for the staff in front of the engine. And so we work together with companies to having software tools which are branded and fixed on our engines, very special, so that you can do the CAM job very easily. So in this example, it's a milling process, but we work on that to integrate our printing process in the same way. Now I will speak short about 2 projects of us. So in this case, we did a substitution from a kind of furniture shelf for a police car, and the approach was to have to reach a good lightweight degree, because newer electrical cars have a higher weight because of the battery weight. And so there is, let's say, as the seek for weight potential in the car. So we did then, or get then, a scan of the inner car, a point cloud, and design afterwards the new shelf parts and geometries. And for that, we designed a special lightweight design with a spline filling in the leather, in the racks itself and in the bottoms, and a special, let's say, fixture design to get it very easy together without any big assembling movements, let's say. And yeah, the requirement was that it holds a 10G. It's like a crash with 20 kilogram on the highest bottom. And yeah, the calculation says it was okay. And afterwards we did a real test with some weight. One package of this granulate is 30 kilogram and was a static test, but the dynamic test comes in the future. Yes, that's the final picture of the hack shelf. Yes, was a great project. The second one is our lightweight and cargo scooter substitution. So the original scooter from our partner ICM is the left one in the green welded assembly frame. And we did a certain lightweight design and did at first design study to compare a closed and an open design, and decided afterwards then that the open design goes more aligned lightweight. Afterwards we did a design which integrates the handlebar bearing and the hack wheel bearing. Then the hack wheel bearing is a kind of Y sheet to guide the forces very good in the frame. And we printed it and milled it for the first time. The first approach was to get it from two parts together, but in the very first time we printed all in all. Milled it afterwards and assembled it, and yes, that is the actual status. You can see it on our booth, C31. Next steps are getting the assembly ready and having tests and calculation comparisons. And with this example, I will finish the presentation and are open for questions.
Thank you very much.
Thank you.
Any questions, just raise your hand and I can bring the microphone out. Or which booth, can you remind me of the booth number to go to find you?
Excuse me?
Which booth number were you on?
Was on the file one, C31 and D29.
Okay. So the process itself, the seam process, is that to be commercialized, to be released commercially, or just for your own research, or what's the ultimate goal for it?
I think it's a little bit from everyone.
Okay.
So it's a big part research, but we also do industrialization with that. We also had one engine by a big textile manufacturer, and we applied there not fiber reinforced thermoplastic, but we apply on textile their elastomer and TPU, and is a kind of killer, let's say. And that is our first big industrialization. And last year we discussed about the ramp up for this described rotational print solution.
Okay.
So, and yes, this software solution which I presented is really important for also that case, because you have to get a very efficient process to get a good business case.
A very, very wide range of potential applications in future.
Yeah.
Perfect. Thank you very much.
Thank you.